Great, thank you. I realize that everybody's leaving. It must be my effect. That's okay. My day job is keeping the good ship EBI sailing the seas and giving the data, such as the UK Biobank, back to you all. But I run a small but perfectly formed research group as well, and we have got into studying this wonderful wild organism called humans, and this wonderful capture of them by UK Biobank, looking at their basic biology. And I'm interested in everything in this wonderful organism, and that includes eyes. And a year and a half ago, I met the wonderful Eye Consortium in Moorfields and have become part of it. So I'm going to just, I can probably skip all of this, we know all of this. But at the end of the major round, as Rory mentioned, the Eye Consortium went to Rory and said, we reckon we can get, if you give us 10 minutes of time, we can do more things than you can imagine with eyes. And these two people, Piyang and Pierce, raised enough money to run this program. So this is a quick crash course on the eye. It is a living tissue that you can image directly at the cellular level, near cellular level, through the lens. It's quite remarkable. And what the many ophthalmologists are particularly interested in is these retinal layers, which actually process light. And so the major technique that we are using or looking at is this thing called optical coherence tomography. This is going into the eye, so the bottom is the bottom of the retina, and that was the fovea, or the actual the place where you do most of your vision, passing through there. The lines, by the way, are blood vessels going through the eye. So we have these data sets to use as potential phenotypes. And there's been hundreds of years almost of understanding the structure of this tissue, and much of it is around these retinal layers, which is shown schematically on the right, and then just the very top layer is shown there on the left-hand side. And so ophthalmologists think of this as a series of thicknesses of these retinal layers across the eye. Eyes also don't only have a sort of thickness and a Z dimension, they also have a space. The OCT scan is centered on that place of highest vision. And there are a couple of standard ways of sort of splitting up the eye, and the way that we are tending to use it is this right-hand bullseye scheme, which splits the eye into 9 different sections looking straight on from this. And there's a piece of the software to do the device to measure OCTs, TopCon, comes with software that will automatically segment these thicknesses and also produce this bullseye. And so over time, all the OCT scans have been processed through the TopCon. We're still waiting for the last 20,000 sets of scans to be processed to give us these figures, these measurements. Now, one interesting thing about UK Biobank from my perspective is its scale. It's great for genetics, but it's great for something else, which Daniel mentioned as well, is you can be really harsh on the QC. So we have been ruthless on the QC of these images at first, and this is probably quite excessive, but we decided to completely discard anything that looked even the slightest bit off when we did this, to give us a super clean data set of 42,000 odd cases. Just to convince you that that makes sense, this is a very simple PCA plot of one of the layers, just showing the first 2 principal components before QC, and the data scientists amongst you will notice there is some disturbing structure in that PCA plot. And this is after the QC. We don't use these PCs to do the QC, and that is a much, much happier first 2 principal components. And we have just, in the last couple of weeks, run our first initial GWASs here. I have learnt not to look at the loci until we're really happy with all of our statistics. So please, no one ask me what the loci are. I officially do not know until we have decided that everything is clean, because as all of us know, as soon as you open the box, you get too excited, and then you keep tracking that one locus down and trying to recover it. So I think this goes to good community practice. Do not reveal your loci until the end. But as you can see, that is a very good-looking Manhattan plot with ridiculous p-values, and the LD regression score is good on this. But these derived variables don't have to just be used for genetics. Here are some very classic things that you might associate some of these variables to. We're just looking here at the first principal components across what ends up being a 93-dimensional space against here height, weight, age, sex, and one of the optical measures, refractive error. And you can see we get some obvious correlations, and we'd like to extend this to the other, many of the other variables in UK Biobank. And those principal components themselves are interesting. Going back to the bullseye, this is a picture of the principal components of one layer across the bullseye. And you can see the first principal component is a general thickness across the entire space. But the other principal components really do look like different subparts of the eye. For the data scientists about this, I think principal components is the first technique you should use. I'm actually not a big fan of it because it enforces orthogonality of all the components past the first one. So I prefer something a little more relaxed. But this shows a lot of promise. But we don't want to stop there, and we already have played around with and would like to develop further, more detailed ways of thinking about the eye, in this case about putting more subset segmentations around this eye framework, and this is work to place a kind of hexagonal grid across the eye rather than that 9-way bullseye from the software. So just to say, we have joined this happy crew of the UK Biobank Eye and Vision Consortium. They do many more things than OCT, and I have had a crash course in eyes just to get to this point. And most of this work was done by Hannah Currant, who's a student who I hope hasn't left yet. And many, many thanks to Praveen, Anthony, Pierce, and Zahana from Moorfields who supported this. So thank you.